In this lesson, we're going to look at proving theorems about angles in parallel lines cut by a transversal. And we've briefly talked about this in class, and you should have already talked about this in your middle school experience. But we're going to go over some definitions of the types of angles, and then we'll look at some examples. The first thing to note is the difference between interior and exterior angles. So again, if I have two parallel lines, remember that is noted by these arrows right here, showing that these two lines are parallel, cut by this transversal, I have an interior space and exterior spaces. Interior is the space between the two parallel lines, so these two and these two, 3, 4, 5, and 6 are all interior angles, and then exterior angles are those angles outside of those two parallel lines, so 1, 2, and 7 and 8. One type of angle we have are corresponding angles, and corresponding angles are angles that are in the same relative position, meaning angle 1 and angle 5 are in the same relative position. Here is my parallel line and my transversal, and it's above the parallel line to the left of the transversal, and then same thing here, above this parallel line and to the left of the transversal. So angle 1 and angle 5 would be an example of corresponding angles, and those are congruent. So 1 and 5 would be an example, 3 and 7, 2 and 6, and so forth. Alternate interior angles, think about what we talked about just a minute ago with interior angles. So we know that they're inside or in between the two parallel lines, and alternate means that they're on opposite sides of the transversal. So 3 and 4, or excuse me, not 3, 4 and 5 would be examples of alternate interior angles because they are on opposite sides. That's the alternate part, right? Opposite sides of the transversal, but both inside or in between these two parallel lines, so in between the parallel lines. Another example of alternate interior angles would be 3 and 6. Same side interior, we're still talking about interior angles. Let's go back for just a second. Alternate interior angles are congruent. Same side interior, again, we're talking about inside or in between those two parallel lines, but now we're talking about on the same side of the transversal. So 3 and 5, they're on the same side. These angles are not congruent, but they are supplementary. So same side interior angles are supplementary. Alternate exterior angles, just like alternate interior angles, are congruent. So if I have 2, its alternate exterior angle would be 7. So both 2 and 7 are on the outside of the parallel lines, that's the exterior part, and an alternate meaning they're on opposite sides of my transversal. Same side exterior is similar to same side interior in that these angles are supplementary, but same side exterior would be, example of that would be 1 and 7. They're both on the same side of the transversal, and they're both on the exterior of my two parallel lines. If my if I have two parallel lines and my transversal is perpendicular to that, then I'm going to have all right angles. So let's look at examples. The first example that we're going to look at is proving that triangle ABC, which is this large triangle, and triangle DEC, which is the triangle on the inside, are similar. Let's split those up for just a second. This is the smaller one, DEC, and then let's talk about ABC. So these are my two triangles, and let's talk about these parallel lines. If these lines are parallel, then these two angles have to be congruent because those are corresponding angles. So angle D and angle A are congruent. E and B, which I should be saying CED and CBA, but those two angles also have to be congruent because those are corresponding angles. So we have angle similar, so I can prove that those two triangles are similar. So let's go ahead and do that in our proof. Okay, we're going to start with our given that AB is parallel to DE. And our reason for that is is our given. Alright, next we said that angle CDE was congruent to angle CAB, and our reason for that was because we had parallel lines. So if parallel lines, and those are corresponding angles, so I'm going to say then corresponding angles are congruent. So remember we said, okay, we've got parallel lines, so these two angles are corresponding angles, they must be congruent. And it's the same thing for angle CED and angle BA. So I'm going to put same as number 2, so the reasoning is the same. And lastly, I can go ahead and say that the triangles are similar because I have my two angles, and that's all I need to prove that two triangles are similar. Alright, my diagram that I'm given that angle 1 equals 3 times x plus 15. And angle 2 is 2x plus 55. And then angle 3 is 4y plus 9. So it wants me to find x and y in the measure of the unknown angles. Now I know that these two angles are alternate interior angles, but if I try and set them equal to each other, since I know they're congruent, it's not going to do me much good because I have two different variables. I have an x in this one and a y in that one, so that's not really going to work. Really, I need to try and compare these two somehow because they both have the variable of x. If you sort of tilt your head to the side, you can see, okay, here is a set of parallel lines, and you could use this as your transversal. Then these two are same side interior angles. Here are my parallel lines, here and here, the ones with the double arrows. So they're both on the inside of those, and they're on the same side of this transversal. And remember that same side interior angles are supplementary. So I'm going to add these two angles together, and I'm going to set them equal to 180. So here I'm going to distribute. I've got 3x plus 45 plus 2x plus 55 equals 180. Add, and I get 5x. 45 and 55 gives me 100. Subtract 100 and I get 5x equals 80. Take 80 and divide it by 5 and I get 16. So my answer for x is 16. When I plug in 16 plus 15 is 31. 31 times 3 is 93, so this angle is 93. And if I take 180 and subtract 93 from it, then this angle has to be 87. Now I could take that 16 and plug it in, but I should get 87. Lastly, I need to figure out what y is and what angle 3 is. Well, I know angle 3 has to be 93 because these two angles are alternate interior angles, so that means that they have the same measure. So then I know that 4y plus 9 has to equal 93. So I'm going to subtract 9 from both sides. 4y equals 84. Divide both sides by, both sides by 4, and I get 21. So y is 21. Alright, lastly, I'm given that these two lines are parallel. I'm given the measure of angle 1 and the measure of angle 2. And it wants me to find the measure of angle EQF, which is this angle right here. Well, based on what I'm given, notice if I were to extend this transversal and extend this transversal, I've got all kinds of craziness going on here. So what I'm going to do instead is I am going to draw in a new line that is parallel to the two that are already there. I'm going to draw it right through Q, and it is going to be parallel to the other angle, or the other lines. Alright, so if that's the case, now I can compare these two angles with these two angles. So this angle and this angle, are corresponding angles, right? I've got two parallel lines and a transversal. So these are corresponding, which means this is 35. And then angle 2 and this angle up here are alternate interior angles. So this would be 65. And then to find EQF, all I have to do is add those two together. So 65 and 35 gives me 100 degrees.